children, welcome to Zero Panic Maths. In today's session, let us continue our discussion on the remaining problems of end of chapter exercises. In the previous session, we have discussed the first three set of problems. If you have not watched that video, the link is given in the description. You can watch that video. Okay, it is the continuation of that. Okay, now the fourth set of problems, simplify the following. There are two algebraic expressions given in the numerator and denominator. This is a rational algebraic expression, you can say. We have to resolve and find the factors of numerator and denominator, and something will get cancelled. We have already discussed some problems like this previously also. Okay, now by looking at the numerator, you can think of it as a plus b whole square. Okay, it is a square plus 2ab plus b square kind of problem. The expression below numerator denominator also, it is looking like a square minus b square, because 1 is actually the square of 1 itself. Okay, now let me write this as 2x square. Okay, you see that I'll write it as 2x whole square plus 2ab. Okay, a now is 2x, so I will write it as 2x. Okay, so it is already 4x, the middle term. Okay, and finally I will write 1 as 1 square. So it is a square plus 2ab. Sorry, there is one missing, right? B value. Okay, and it is b square. Now you can say a is 2x and b is 1, and it is a plus b whole square. Okay, fine. Okay, now let me write the denominator. Denominator is 4x square. I can write it as 2x whole square minus 1 square, and this makes it as a square minus b square. So the upper one, sorry, the numerator one, I can write it as 2x plus 1 whole square. It is a plus b whole square, right? Now below is 2x is a and 1 is b here, and it is 2x plus 1 and 2x minus 1. We know this, right? Because it is a plus b and a minus b. Now what happens here is 2x plus 1. We have the square of that in the numerator. So I can write that 2x plus 1 as 2x plus 1 and 2x plus 1. The square, I've written it in two terms so that I can get it cancelled with the below term, and that is 2x plus 1 cancels with 2x plus 1. What remains is 2x plus 1 in the numerator and 2x minus 1 in the denominator. Okay, so this is what the simplification of this. Okay, so we have identified the actual identifiers that fits into this algebraic equation, so that we can simplify the overall expression. Okay, so this is what the example 1. So the problem number 1 of the fourth set. This is second one now. Now second one, you can see that it is looking like a cube minus b cube formula. Okay, and here it is a square minus b square formula. Okay, but before that you need to observe one thing, that I can take 9 common from here and 3 common from here. Until and unless I take those common things, I cannot make the numerator as a cube minus b cube, because 3 is not a perfect cube and neither the 24 is a perfect cube. Okay, so what I'll do is, just listen to me carefully. Okay, 9 is already there common. I will just take another 3 common out of it, so that it becomes a cube. Okay, a cube, it is a perfect cube, and here 3 8s are 24. 8 is a perfect cube, so I can write 24 b cube as 8 b cube now, because I've taken 3 as common thing. And here also, though 9 is a perfect square and 36 is a perfect square, I can just take out 9 common, so that I can cancel that with the numerator 9. Okay, so that it is, anyway we are simplifying it, right? So something is getting cancelled in the beginning itself. Let us cancel those. Okay, so 9 I have taken it as common, and what remains inside is a square, and 9 4s are 36, and it is b square, though again 4 is a perfect square only. So at the step of simplification, first step, I'll cancel the 9 values from both numerator and denominator. So let us keep 3 as it is and write a cube minus b cube. Okay, so that is a cube minus b is 2b now. Okay, because 8 is a perfect cube of 2. Okay, and then write it as, so a cube minus b cube. Let us expand that in the next step. Okay, let us write this also as a square minus b square, where b is 2b. Okay, 2b whole square. So we will expand the numerator by a cube minus b cube formula and the denominator by a square minus b square. Let me write the identifier that satisfies a cube minus b cube first. Okay, so I will just write that for the reminding purpose. Okay, it is a cube minus b cube is equal to a minus b into another bracket a square plus ab plus b square. So this is the formula, we are using it into the numerator. Okay, so just underline this. Okay, and let us apply that formula here. So 3 in the numerator will be kept as it is, and a minus b, where b is 2b here and a is a only. Okay, so let me write that as a minus 2b. Okay, and then into another bracket a square is a square only plus ab is a into 2b, right, because 2b is b for us, and then finally b square, which is 2b whole square. Okay, divided by a square minus b square. Here also a is a and b is 2b, so I will write it as a plus 2b and a minus 2b. Correct, a minus 2b. Okay, now let us expand this or let us multiply a into 2b and 2b whole square, and let us write the final version of that. Okay, let me write it here. Okay, 3 is kept as it is, a minus 2b is there as one bracket, a minus 2b. Okay, and into another bracket it is a square plus 2ab. Okay, a square plus 2ab plus 4b square. Okay, it is 4b square. So if it would have been only b square, we would have written it as a plus b whole square, but it does not fit in here because it is a square plus 2ab plus 4b square it is. So don't do anything with that, it will be kept as it is. Okay, what is there in the denominator is a plus 2b and a minus 2b. Let us write that a plus 2b and a minus 2b. What is that is getting cancelled is a minus 2b and a minus 2b, and the remaining things like a and a square plus 2ab plus 4b square, 4b square in the numerator, and then the denominator a plus 2b. Okay, so this is the simplified version of this given algebraic rational. Let us quickly move to the next problem. Okay, so that is the third one. Now a cube plus b cube, it is looking like a cube plus b cube, another identity that we know already, and it does not look like any of the identities, so we have to solve it by the factorization method, the regular factorization method of splitting the middle term and all. Okay, so let me write the above one as s cube. Okay, just listen to me carefully. S cube plus 125, I am writing it as 5t whole cube. Okay, 5t is now b for us, and a is s cube plus 5 2 whole cube is the numerator one. Okay, the below the denominator, see it is now 35 and it is minus 2st. Okay, so I will write this as minus 35. Okay, and what are the two factors that multiplying which I will get is 35 is 7 and 5. Okay, 7 5s are 35 and 5 minus 7. Okay, 5 minus 7 will give me minus 2, the middle term minus 2. Okay, hope you are getting this. Okay, so there is a 35 here, so let me split the middle term s square. Now why did I not went to any of the identities because the first and last terms, which are the squares, are not perfect squares. 35 is not a perfect square of any integer. So that's the reason I went to this middle term splitting. Okay. So minus 7x minus 7, sorry, it is 7st. Okay. Whatever variables are there, you have to keep that only. And plus 5st. Okay. Listen carefully. And while writing also, you need to keep both these. Okay. Minus 35t square. This is what is there in the denominator. Okay. Now let us write a cube plus b cube. Okay, let me write that formula first. A cube plus b cube is equal to a plus b. Okay, in one bracket, and in another bracket. Hope you are looking into all the identities that what we have studied in this class. Okay, in this chapter. Okay. Now let us write a cube plus b cube in this version. Okay. What is a here? A here is s, and b is 5t. So it is s plus 5t, that is a plus b. Okay, the above one I'm writing. Okay, and next is s square, that is a square, s square minus s into 5t, that is minus ab, plus 5t whole square, 5t whole square, that is b square. Okay, divided by what we have to do is taking common from this. What does the common comes from the first two terms? First two terms, s is the only thing that is common. So I can take s as common, and what remains here is s minus s. This s comes as common, so 7t remains. 7t remains as the term here. So from the second set of two terms, plus 5 comes as common, and even t is there here, t is there here. So let me take 5t as common. So what remains here is, in this term, you see that yes, minus 5 sevens are, it is 35, and 1 t is going out, so another t is remaining, that is 70. Obviously it has to match this so that we can take it common. Okay, let us write the next step. Next step is s plus 5t is kept as it is, s plus 5t. Okay, and then s square minus 5st, 5st. Okay, plus 5 square and t square, that is 25t square, that is the expansion of the second bracket, and then take s minus 70, s minus 70. You're getting it right, because it's a simple one and we have done this so many times. So s minus 70 came as common, so what remains here is s plus 5t. S plus 5t comes as the bracket. So what it get cancels is s plus 5t, and s plus 5t get cancels, and what remains is s square and this term divided by this term. So let me write that as s square. Don't get it confused with 5 square. Okay, it is not 5, it is s. Okay, minus 5st, 5st. Okay, I'm purposefully writing 5 little bit different from s. Okay, plus 25 t square. Okay, 25 t square divided by what remains is s minus 70. S minus 7t. Okay, so this is what the final answer. Let us quickly move to the next problem. The fifth one. Okay, fifth one is some description of the problem given. Find the possible expressions for the length and breadth. Okay, length and breadth we are finding out of each of the following rectangles. So there is a rectangle area, it is given here. Rectangles whose areas are given by the following expressions in square units. Okay, so these are the areas of the rectangles given. So the area of the rectangle, as you know, is calculated by multiplying side 1 and side 2. Okay, there are two different sides will be there, and this is the area of one rectangle and this is the area of one rectangle, as you know. Okay, now considering area of the rectangle here is equal to area of rectangle is given by this expression, correct? So that is 25 a square minus 30 ab, okay, plus 9 b square. So when you get the factors of this, it will be in terms of a and b, and there will be two factors. One factor will be the length and another factor will be the breadth, because multiplying one factor to the other factor, you are actually going to get this expression, and that expression they are saying it is a area of the rectangle. So here they are not giving anything new, but what they are asking us to find out the factors of this algebraic expression, and the factors itself will become length and breadth in square units. Okay, that's all. Okay, let us find out the factors of this. 25 a square, I will write it as 5a whole square, okay, minus, I'm writing it as a square minus 2ab plus b square format. Okay, so 2a, what is a is 5 I know that. Okay, so what is the middle term? Minus 30ab. It is already 2 5s are 10a, and b is required, and 10 3s are and b. You now see that 2 5s are 10, 10 3s are 30, 30ab. Okay, that is the middle term. And then we got 3b as the value of b by this expansion. So I can write directly 3b whole square as the b square value. Okay, 3b whole square is 9b square. So now you got this 5a as a and 3b as the value of b. So I can write this as 5a minus 3b whole square, and that is 5a minus 3b and 5a minus 3b. I've multiplied this twice. So this is length and this is breadth. Both length and breadth are equal. So it cannot be called as a rectangle, but it is a square because of the same side lengths. Okay. So therefore you can say length is equal to breadth is equal to the same value, right? So it is one is length here and one is another is breadth, but having the same value 5a minus 3b. This is the solution to this. Okay, considering this as area, this is length, this is breadth, multiplying these two, I will get this expression, and that expression is area of the rectangle. Similarly here also we have to get the factors of these this expression, and those are one is length and another is breadth. Now this looks like a square minus b square formula because 36 and 49 both are perfect squares. Okay, so let me write 36s square as 6s whole square, that is 6 square 36s square minus 7t, because 7 square is 49 and t square. So 6s is a, 7t is b, it is a square minus b square, and the formula expands to 6s plus 7t, that is a plus b. Okay, and then 6s minus 70, that is a minus b. So this is length, you can write it yourself. Okay, this is length and this is breadth. Okay, so you have to finally write that length is equal to one term is length and another term is breadth. That's all. Okay, so it's a simple one. Again, going to the next problem, sixth one. Find the possible expressions for the length, breadth, and height. Here it is a cube now. Now see, when the formula is where in terms of squares, then it was only two dimension. One is length and another is breadth. Here there will be three factors in these two expressions. One factor is representing length, another is breadth, another is height. Okay, so resolving these expressions, you are going to get three factors. Okay, and that is what they wanted: length, breadth, and height of each of the following cuboids. They are saying cuboids. And while studying a plus b whole cube formula, we have seen that the cube always represents the area of the cuboid, area or volume of the cuboid, actually volume of the cuboid. Okay, whose volumes, okay, they have already given here, whose volumes are given by the following expressions in cubic units. Let us write this expression in terms of three factors, or resolve this expression to get three different factors. Now, looking into these two expressions, you might be thinking that there is a square here. Okay, and here it is also looking like an expression which gets us a square. Then how are we saying that this is going to give us three factors? Okay, that is the catch here. Okay, listen to me carefully. Before you resolve this expression to get three factors, take 6 out of this. 6 is common here. Here also 3 is common. If you take those two values as common, listen to me carefully, those two values, the common values, will become one factor, and that one factor can be represented by any of these, either length, breadth, or height. Okay, let us assume length is equal to that constant value, and the remaining two factors, that what we get after resolving this, one will be breadth and another will be height. You got my point? Okay, let us do that. Let me take 6 as common here first. So if I take 6 common, it will be a square minus 6 4s are 24, right? So it is b square. Now it is a square minus b square format, but there is one factor that is equal to 6. It is already there. Okay, and that 6 will be, we will consider it as length. Okay, okay. So hope you understood this. So 6, I will keep it as it is, and one of the factor is 6 only. Okay, and let me write a square minus 4b as 4b square as 2b whole square. If have to write this step, okay, don't skip this step, otherwise it will be confusing. Okay, so a here is a only and b here is 2b. So let me write, keeping 6 it is as it is, let me write this as a minus b and a plus b. A is a only, so a minus 2b, it is a minus b, and a minus a plus 2b is a plus b. Okay, it is a minus b, a plus b of a square minus b square format. Now this is one factor, this is one factor, this is one factor. You got three factors. Okay, so you can say therefore length is equal to 6 units, and this is in cubic units. Okay, so this is the overall volume is in cubic units. Okay, whereas each of these parameters, length and uh, breadth and height, are in units. Okay, length, breadth. Okay, okay, length we have considered it as 6 unit. So breadth is the one factor, that is a minus 2b units, and finally it is height. Okay, height is equal to another factor, that is a plus 2b. You got the three factors. Let us resolve this also. Here also the similar thing will be followed, similar rule. Let us take 3 as common, which will be treated as one of these parameters. Okay, 3 if I take common, what remains inside is ps square, or else sorry, what we can do is p is also looking common, so let us take 3p as common, 3p as common, so that it will be left with s square in the first term. Okay, minus 3 5s are 15, so p is also went out, so it is 5s that remains inside the bracket, plus among the 12 it is 3 went out, so 3 4s are 12, p is already went out, so it is only 4 here. Let us split the middle term so that we will get the 4 value as the product, and sum we will get as minus 5. Okay, how do I do that? 3p, let us write that. Okay, let me write the product and their factors. Okay, I want the product to be 4 and the factor to be the sum to be minus 5, so it will be minus 4 and minus 1. Okay, I will write it as like this. So 4 into 1 is 4, minus 4 minus 1, I will get it as minus 5. Okay, so let me split the middle term in this way. Okay, so s square minus 4s minus a single s plus 4. Okay, so this is what I splitted the middle term. Okay, let us keep 3p as it is and write the common thing out of this. What is common? S is common. So what remains inside is s minus 4. Here s plus 4 is already there. So I already told you that if you have to take minus 1 common out of this, then what remains here is s. See, minus 1 into s is minus s. I want a 4 here, so I will write minus 4. That is minus 1 into minus 4, that is plus 4. So it is the completion of the bracket. Again, you will keep 3p as it is, and s minus 4, I will take it as common, s minus 4 and s minus 1. What remains inside the bracket. So we got three factors. Let us consider this as length. So therefore length is equal to 3p. Okay, and breadth is equal to the one factor, that is s minus 4. Okay, and height finally is equal to the remaining factor, that is s minus 1. Okay, so these are the factors, and in turn these are the length, breadth and height. Let us quickly move to the next problem, the seventh problem. Okay, now it also will be representing indirectly to any of the algebraic equations, solving which we will be getting the result. Okay, so let us read the problem carefully. The village playground is shaped as a square of side 40 meters. Okay, there is a square playground of 40 meters side. One side is 40 meter, so the other side will also be a 40 meter only. A path of width s meters, okay, it is not 5, s meters, okay, is created around the playground for the people to walk. Okay, and finally we have to find an expression for the area of the path in terms of s. Okay, now it is the problem is expressed like this. Okay, let me draw that problem. Okay, assume that this is the square playground. This is the playground square of side 40 meters. So this is 40 meter, this is 40 meter. This is the playground. Now what they are saying is a path of width s meters is created around the playground. A path of s meter width, okay, is created around the square, okay, around the square playground. Let us draw that also here. So see, there is another square that this path is making outside the inner square. You're getting my point? Okay, now let me write this as, see, this is 40 meters. Okay, this length is 40 meter as it is given. Just imagine this. Okay, and what is this length? They are saying this length is s meter, right? Here it is s, and this is also s meter. Okay, so what is the length of the outer square? What is the length of the side of the outer square? See, this is 40, this is 40. Listen to me carefully. This part is 40, this is s, and this is s. So the overall length is 40 plus s, that is 2s. Okay, so considering the given information, I can get the outer square's side length is 4 plus 2s. Okay, so let me write that given is length of the side of the inner square, length of side of inner square, that is actually a playground. Okay, a side of playground, or you can say inner square only, because I'm going to just subtract the area of the inner square from the area of the outer square to find out the area covered by the path. What is that they want is find an expression for the area of the path in terms of s. So what we want is this area. You're getting my point? This area, what is this area covered by? How do I find out that area? It's very simple, that you will find out the area of the outer square that will cover the whole area, and you subtract the area of this inner square from that. That will give you the area covered by this path. That is what I'm trying to do here. You're getting my point? Okay. So let me write that length of the side of inner square is actually 40 meters, that is given. 40 meters, that is given. And similarly, length of the outer square, length of the side of outer square, side of outer square, that is outer square, is equal to, so it is 40 plus 2s meters. Okay, 2s meters. So what I'm will do now next is take the square area by this as one side, that will give me the outside square, sorry, area of the outer square. Okay, so therefore what is this area of the path, area of the path, area of the path is equal to, path is equal to area of the outer square. What is that? It is 40 plus 2s whole square, right? That is the side. So side into side will give you the area minus area of the inner square, that will give me this. Okay, I will explain it multiple times, so let me write that in mathematical terms. Okay, so this is expanded at a plus b whole square minus 40 square. Okay, so let me expand that. A square, that is 40 square, plus 2ab, 2a is 40, b is 2s, plus 2s whole square, that is b square, minus 40 square. This minus 40 square, I'm keeping it as it is. So plus 40 square minus 40 square got cancelled, and what remained here is 2 4s are 8 and 8 2s are 16. 160 yes is what remained. 160 yes, right? It is plus, so 160 yes remained. And what other term that is remaining here is 4 yes square. 4 yes square is what is remaining. Okay, anything that I can get outside from this is 4 will come as common from 160, and from here also yes is also common. So let me take 4s as common, and what remained inside is 4 4s are 16, and that is 40 plus 4s came out, so 40 plus yes. Okay, so this is the area of this path in terms of yes, in terms of yes. See, 4s multiplied by 40 plus yes meter square. Okay, so this is what the area covered by this path, which is around the playground of the side 40. Okay, and the width of this path is yes, it is given in terms of yes. Okay, hope you understood this. So let us quickly move to the next problem. Okay, so the next problem is a generic solution here. If a number plus its reciprocal equals to 10 by 3, then find the number. It's a very simple problem. We have done such problems in the linear polynomials also. So let us consider that number as x, take the reciprocal of that, add both, and make it equal to 10 by 3. It will get you an expression. You have to resolve that expression. Okay, it's a simple one. Okay, so let the number be, because we don't know the number, let the number be is equal to x. Okay, and then the reciprocal will be, reciprocal means the reverse of that, 1 by, okay, reciprocal equal to 1 by x. And what they are saying given is the number plus its reciprocal is equal to 10 by 3. So therefore x plus 1 by x is equal to 10 by 3. Okay, so add x plus 1 by x, that is taking x as the LCM, it is x by 1 we are writing. Okay, so it is 1 x, the x will get, so x square. Okay, you have to do it carefully. X square plus 1 in the numerator of this is equal to 10 by 3. Okay, so the cross multiplication, it is 3 into x square plus 1. Okay, we have taken 3 this side and x to that side, that is 10x. Okay, so it will be 3x square plus 3. Okay, so I will write it as 3x square plus 3 and minus 10x, sorry 10x, I will take it to the left side, it will be minus 10x and it is equal to 0. Okay, let us write the minus 10x in the middle term and the constant 3 to the right side, and this will be an algebraic equation that we can resolve. Okay, plus 3 is equal to 0. Okay, now you see we have to take the multiplication of the coefficient of x square and the constant term, that is 9. Okay, plus 9, and there is a minus 10 here, so it is 9 ones are 9, that gives us that required product, and both are minus. Okay, minus 9 ones are 9 and minus 9 minus 1 will be minus 10x. So let me write that as 3x square minus x minus 10x or minus 9x, anyway you can write it as. Okay, plus 3 is equal to 0. So splitted minus 10x into minus x and 9x. Okay, so from the first two terms, x will be coming as common, and what remains inside is 3x minus 1. Okay, 3x minus 1, and from here it is 3 that comes in with negative sign. Okay, because there is a negative here. Okay, 3 threes are, and x remains inside, and there is plus 3 already, so it is minus 3 which came out as a common, so it will remain as minus 1. Okay, obviously it has to match this. Okay, so hope you are getting this. Okay, take 3x minus 1 as common, this is common now, so 3x minus 1 is taken as common. What remained here is x and minus 3, x and minus 3. Okay, so I forgot here, this is already equated to 0. So if since these factors are equated to 0, either this should be equal to 0 or this should be equal to 0 to make the whole equation as 0. So let us equate both 3x minus 1 to 0, or x is equal to x minus 3 is equal to 0. That actually gives us one x value as minus 1 taking to that side, and 3 will come here. One x value as 1 by 3, and another x value minus 3 taken to that side, another x value is 3 plus 3. So it is actually, if you consider x is equal to 3, then the reciprocal will be 1 by 3. If you consider x is equal to 1 by 3, the reciprocal, the reverse of that will be 3, and both will satisfy the given condition. Let us quickly move to the next problem. Okay, now the next problem is a rectangular pool has an area. Again, an algebraic expression representing an area is given here. 2x square plus 7x plus 3 square hastas, it is given. Hasta is one of the unit of measurement. Okay, finally they are given. Hasta was unit used to measure length. So it is hasta. Nothing, you don't get any details about this. Okay, don't think about it. It is just like a unit. Okay, square units. Instead of that, they have written it as hastas. So this is the area. If its width is given as 2x plus 1, we have to find the length. So length into width is actually this area, and among that width is given, length we need to find out. Understood? Okay, let us do that with the length into width only. So given is width into length is equal to area. We know that, right? Okay, we know this formula that if you multiply width to length, you will get the area. Width is already given. What is that? Width is 2x plus 1. Okay, let us substitute that. Okay, and keep length to be found. Okay, and what is area? Area is also given. You see that rectangular pool has the area. What is that? 2x square plus 7x plus 3. Okay, now we want length, right? So therefore, what is length then? Length is equal to, this is the area divided by this. We can do that finally, right? Okay, so let me write 2x square plus 7x. Again, you have to multiply coefficient of x square to the constant term, and that is the 2 3s are, that is 6, and the middle term is 7x, so it will be 6 1s are 6. Okay, multiplying which will get you 6, and adding 6 to 1 will get you 7x. Okay, so let me write that as 2x square plus 6x plus x plus 3. Okay, and I will take this 2x plus 1, which is width. Because I want a length, I will take it to the denominator as 2x plus 1. Okay, so this is like an algebraic rational solving, which will get any of these factors in the numerator will get it cancelled by the denominator, so that we will get a length. Okay, let us take common from the first two terms. 2x will be common, as you know. Okay, 2x is common. Okay, I'm talking about numerator only. Okay, so x here remains, and there is a 3 that remains, x plus 3. You see that 2x into x is 2x square, 2x into 3, that is 6x. Okay, so there it is already x plus 3. We want x plus 3, so you know that what comes in as common is 1. So what remained inside is x plus 3. Okay, so this is what the numerator is. Denominator, I will keep it as 2x plus 1 only. 2x plus 1. Okay, now take x plus 3 as common. So x plus 3 came as common from the numerator, and what remained here is 2x plus 1, and that 2x plus 1 is going to be cancelled with the 2x plus 1 in the denominator. 2x plus 1. Okay, finally we will cancel this and this, and what remained, x plus 3. X plus 3 is the required length. Okay, length in what unit it is, hastas. Okay, so therefore you can say length of that rectangular pool is, length is, what is that, x plus 3, what is that, hastas. So if you multiply x plus 3 to 2x plus 1, you are obviously going to get 2x square plus 7x plus 3. Okay, you understood this, right? Okay, let us quickly move to the next problem then. The 10th problem says if both x minus 2 and x minus 1 by 2 are the factors of this. Okay, there is an equation given, and the factors of this equation are also given. Show that p is equal to r. There are two variables here, p and r, not p variables but constants. Okay, it is, one is coefficient of x square and another is a constant. So we have to show that the coefficient of x square is equal to constant when the factors of this expression are x minus 2 and x minus 1. In generally, what we will do is, since let me write that, since x minus 2 and x minus 1 by 2, okay, are factors of, are factors, okay, we can write it as, we can write this expression. Okay, so we can say px square plus 5x plus r is equal to, actually multiplying these two only, it should get this, right? For a constant k, these factors will make the given expression, x minus 2 and x minus 1 by 2, for k an integer. Okay, k is an integer, is an integer. Okay, now let us resolve this by multiplying x minus 2, x minus 1 by 2, and equate those values with the coefficient of x square and the constant terms. Okay, let us keep k as it is, x into x square. Okay, that is x into x, x square, minus x into 1 by 2, that is x by 2, minus x by 2, minus 2 into x, that is minus 2x. Okay, and minus into minus plus, and 2 into 1 by 2, that is 1, and this is equal to k multiplied by x square minus x by 2 and minus 2x, that will be minus 5x divided by 2, or you can say 5 by 2x, so that it matches with the x term here. Okay, minus sorry, plus 1, that is what remains. Okay, let us multiply k also to all the terms. Okay, it is kx square minus 5 into k, that is 5k divided by 2x plus k. Okay, and that is equal to px square plus 5x plus r. Okay, you got my point. Okay, now if you equate both the algebraic expressions here, k is equal to p here. Okay, so therefore I can write it here. Therefore p is equal to k. P is equal to k, the coefficient of x square, it is p is equal to k. Coefficient, so the constant term r is equal to also k. R is equal to also k. Okay, so if p is equal to k and r is equal to k, therefore p is equal to r. So this is how you proved it. Okay, so you may ask me the middle term, why we did not consider middle term also. If you consider middle term also, the coefficient of x square, coefficient of x, that is 5 here and minus 5k by 2 here. Okay, even if you consider that also, it will be like minus 5k divided by 2 is equal to 5, right? Okay, so this 5 and this 5 got cancelled, and what is the value of that is k is equal to minus 2. So it will actually reduce to a constant value given for k. So even if you consider this, p is equal to k and r is equal to k, and that k is equal to minus 2. So in that case also p will be equal to r. So it is a simple question. If you multiply the two factors with a constant k, because for any constant we need to consider these coefficients, that's why I've taken this k. Okay, there's no confusion in that. So finally when you expand the multiplication of both the factors, then you will get p and r will be equal to that one constant k, and that's the reason where we got this result as p is equal to r. Okay, understood this? It's a simple one. Next, problem number 11. Okay, now this is somewhat interesting because we are going to use the different identities here. Okay, so the given is a plus b plus c is equal to 5, ab plus bc plus ca is equal to 10. Then prove that aq plus bq plus cq minus 3abc is equal to minus 25. You see that there is an identity that represents this as one part of that identity. Let us consider from there itself. Okay, so a cube plus b cube plus c cube minus 3abc, this is what they are saying, right? Minus 3abc, and we know that the formula for this, or the expanded version of this, is a plus b plus c. Okay, sorry, let me write this here itself, and this is actually expanded to a plus b plus c in one bracket. In another bracket it is a square plus b square plus c square, okay, minus ab minus bc minus ca. This is what the expansion of this. Okay, now let me, I know the value of this, that a plus b plus c, that is equal to 5. Let me put in that value. A plus b plus c is equal to 5, it is given. ab plus bc plus ca is given. Listen to me carefully here, but here it is minus ab minus bc minus ca. So if I take out minus as common, this whole three terms will become ab plus bc plus ca, so that I can substitute the value of 10 there. You're getting my point? The only thing that is uncalculated will remain is a square plus b square plus c square. Okay, if you get the value of this sum also somehow with a different identity, then this problem will be resolved. So let me substitute a plus b plus c is equal to 5 here, and then keep a square plus b square plus c square as it is. Okay, and listen to me carefully, I'm taking minus common from all these three terms. So what remained inside is ab plus bc plus ca. Okay, Why did I took minus common? Because I know the value of AB plus BC plus CA is equal to 10. Okay, and that is equal to 5 multiplied by A square plus B square plus C square minus, substitute the value of this, and that is 10 minus 10. Okay, now till this point only we can reduce this equation because we don't know what is these expressions are. So let us write this as equation 1 and keep it as it is, and start with another identity to get this value, provided the values of a plus b plus c and this one. Okay, let us be concentrated here. And now we know that, now we know another identity, that is a plus b plus c whole square. Okay, you remember this formula, a plus b plus c whole square is equal to a square plus b square plus c square. Remember this or not? A square plus b square plus c square plus 2 times of ab. It is actually 2ab plus 2bc plus 2ca. You can take that 2 common and write it as 2 times of ab plus bc plus ca. This is the one of the identity that we already know. So by this I can calculate this set of the sum of squares of the variables, so that I can get this whole value of expression 1, equation 1. Okay, you getting my point? Okay, now let us just keep this value a plus b plus, sorry, a square plus b square plus c square, write it here, a square, therefore a square plus b square plus c square, I'm writing it as it is, and this is a plus b plus c whole square. What is a plus b plus c? It is already given here, that is 5. Okay, so let me write that as 5 square, and I'm taking 2 times of this to the left side. Okay, so it will be minus 2 times of, what is ab plus bc plus ca? That is also given, that is 10. You got this? Let us calculate the value of this. That is 25 minus 2 times of 10, that is 20. So the whole value of this is 5. What is the value of this? Okay, so let us don't mark it as an answer. Okay, it is a plus b plus c. Sorry, it is not a plus b. A square plus b square plus c square as equal to 5. Let us mark this as equation 2. Now substitute, this is what is required here, right? So substitute equation 2 in equation 1. Substitute, you can say substitute 2 in 1. Equation 2 in equation 1. What I will get is a cube plus b cube plus c cube minus 3abc. That is what is required, right? A cube plus b cube plus c cube minus 3abc is equal to 5 times of a square plus b square plus c square, that is 5. Okay, so let me write this as 5 times of 5 minus, what is that, 10, 5 minus 10, and that is equal to 5 into 5 minus 10, that is minus 5, and that is equal to minus 25. And this is what the proof required. That you understood this, right? Let us quickly move to the 12th problem. Okay, now 12th problem, since there was something required to be descriptively written, so I have already written it. You can just make a note of this. So 12th problem is little bit different. By factoring the expression, by factorization, check that n cube minus n, we have to find out the factors of this. N cube minus n is always divisible by 6. It's a very simple and basic problem that of divisibility we are checking it here. Okay, n cube minus n is always divisible by 6 for all natural numbers n. We need to prove this and give the reasons. This is a simple expression, simple problem. Okay, let us start with n cube minus n. I will take n as common. If I take n as common, then it remains with n square minus 1, and which matches with a square minus b square. Okay, so that I am writing it as a plus b, a minus b. You're getting this, right? Or you can write it as n minus 1 the one number before the n and n plus 1 number after the n. Okay, so it is first number, first integer, second integer, and the third integer. So it is actually the product of three consecutive integers. This product is looking at three consecutive in series numbers, only three consecutive numbers. So if the product has three consecutive integers, it's very simple. Just see that among the three numbers, one should be even. If there are continuously three numbers given, 1, 2, 3, 2 is common there. 3, 4, 5, 4 is even there. 5, 6, 7, 6 is even there. So if you consider any three consecutive integers, there will be one number which is even. You understood this, right? So that is why we say that the product has a factor of 2. And similarly, among the three numbers, because these are the three consecutive numbers, one should be multiple of 3 also. So it has a factor of 3 also. So the also it has a factor of 3. You're getting my point, right? Therefore, we can say that the product has both the factors of 6, which is written as 2 into 3. So it has a factor of 3, factor of 4, 2. So we can say it has a factor of 6 also, because 2 multiplied by 3. If the product has both the factors 2 and 3, so obviously it has to have the factor of 6 also, right? That is what the conclusion here. So finally, if it has the factor of 6, then it should be divided by 6. That's what we are saying. So finally, we can write it as, so n cube minus n, which is the initial expression given, is now reduced to n into n square minus 1, and finally the product of three consecutive integers is divisible by 6 for all natural numbers n. This is what the conclusion. Okay, so there is some descriptions written here. That's why I don't wanted to waste time on writing these things. That's why I've already written it. Okay, yeah, I think you got this. Okay, let us quickly move to the next problem. This is the last problem in the end of chapter exercises. There are two different problems here. Find the value of this when x plus y is equal to minus 4. Okay, so listen carefully here. It's a very interesting problem. Okay, so now here if you look at this, it is a cube plus b cube plus there is a c cube here and minus 3xy z kind of problem it is looking like. Okay, let me write this as x cube, okay, plus y cube plus 64, we will write it as 4 cube. Okay, and minus 3xyz, I will write it as 3, x is x, okay, y is y, and z is 4. You understood, right? Okay, you see that 3 4s are 12 and xy. So I've written it as a cube plus b cube plus c cube minus 3xyz, or sorry, 3abc. Understood? So what is this formula is about? Is a plus, okay, let me write that. We have just used this formula, that a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, okay, into another bracket a square plus b square plus c square minus ab, okay, let me write it here, minus ab minus bc minus ca. Okay, so this is what the identity that what we are using here. Okay, let us write here a is x, b is y, and c is 4. Okay, so let me write this as a plus b plus c as x plus y plus uh, 4. Okay, x plus y plus 4 multiplied by a square plus b square, that is x square plus y square plus 4 square minus ab. Ab is x and y minus xy minus bc, that is y and 4, that is 4y minus ca, that is 4 into x, that is 4x. You don't have to worry about this, because this term x plus from given, okay, you see here, okay, just listen to me carefully. From given, see what is given here is x plus y is equal to 4 minus 4. X plus y is equal to minus 4. Okay, therefore what is x plus y plus 4? Take this minus 4 to the left side is equal to 0. See, x plus y plus 4 is equal to 0, correct? So let us substitute this x plus y plus 4. This whole term is equal to 0. The multiplied to this, so that will be equal to 0 multiplied to this whole term. You can write this whole term here. Okay, I will not spend time on that. So this whole term, if you write it here, 0 multiplied to 0, so the whole thing is equal to 0 only. Similarly, this also is done like that only. Okay, let us do this. It is also expanded by the same factor only. Okay, it is a cube. Let me write that. Okay, or let us first write this only. So given is, let us write this. Given is x minus, I will take 2y and 6 to the left side, and it will be x minus 2y minus 6 is equal to 0. Let us keep this as equation 1. And finally, when you reduce this expression, you are going to get this x minus 2y minus 6 as one of the factor. Substituting that 0 will lead to the whole expression value as 0 only. That is what is going to happen here also. Okay, now let us write this as x cube minus, so I want it should be a cube plus b cube plus c cube format, right? So I'll write plus, and minus 8 I will write it as 2y minus 2y whole cube. I'm writing it as minus 8y whole cube, because this minus I want it to be made as plus. Now minus 2 cube will be minus 8 and y cube, so that's why I'm writing this like this. So it is minus 216. I will write it as 216 is actually 6 cube. I can write it as minus 6 cube, considering c value as minus 6. And if you multiply minus 6 thrice, it will get you minus 216 only. So it is a cube plus b cube plus c cube, where a value is x, b is minus 2y, c is minus 6. Now let me write this as minus 3abc. 3a is x, we know that, and b is minus 2y, b is minus 2y, and c is minus 6. C is minus 6. See, it is 3abc. Now you multiply and see whether it gets to you minus 36. It is minus here 3 into x, or you multiply the constants first. Minus 3 into minus 2, it is plus 6. Plus 6 into minus 6 is minus 36. There is x here, there is y here. So it is minus 36 xy. It is 3abc. Hope you understood this. Okay. Now let us write a plus b plus c. This same formula. If you want, you can write that again once here. So it is a plus b plus c, that is a plus b, that is minus 2y, plus c, that is minus 6. See, this is what that term is, and you are going to substitute this as 0. You got my point? Okay. Now next is a square, this term. Now a square plus b square plus c square minus ab minus bc minus ca. Let us write that, but anyway it is going to be evaluated to 0 finally. It is a square plus b square, that is 2 minus 2y whole square, okay, plus c square, that is minus 6 whole square, okay, and minus ab, that is x into minus 2y, x into minus 2y, it is minus ab, minus bc, that is minus 2y into minus 6, and minus ac, that is minus 6 into x, minus 6 into x. But this whole term, anyway, if you expand also, this is going to be substituted. So from equation 1, I already written equation 1 as x minus 2y minus 6 is equal to 0. So I can substitute this value as 0. 0 multiplied by whatever you get by expanding this. You write it here. You expand this. Expanding means minus 2y, it is 4y square, it is 36, and this is minus into minus plus 2xy. All that you can write it yourself here, but anyway whatever you write is multiplied to 0 will finally get you 0 itself. So both these expressions given with the different algebraic simple algebraic expressions, if you substitute those, the final value of both these expressions is going to be 0 itself. Okay, so this completes the end of chapter exercises of chapter 4, exploring algebraic identities. Finally, if you can see the chapter summary, there are 11 different kind of algebraic expressions we have already studied. I will not go through all these expressions because in some or other problems we have used all these identities. Okay, just make a note of these 11 identities and go through those identities, remember those identities. Okay, so this is what the chapter 4, exploring algebraic identities. Hope you have understood all the identities and the problems related to that. Okay, let us meet in the next session with a new chapter, chapter 5. Okay, thank you.